Hope you're having a great Cloud Next so far. Really great to see you, everyone. My name is Niranjan. I'm a VP at Google working on our developer AI efforts. Joining me today is my colleague Madhura, who's an engineering director on our team. And together, we are going to talk about the agentic shift in software development that is happening at Google. How are we navigating it as a company? What lessons are we learning? What challenges are we solving beyond sort of just using all of these products? So let's get into it. It is no surprise that the agentic coding workflows are accelerating throughput. But by how much? Today, Sundar Pichai announced that about 75% of all new code is written by AI. Here's another interesting stat. Just in the last 12 months, Google added more code than it had in roughly the past 3 years before that. Right? So the amount of code being generated is huge. About a third of all changes that are being submitted at Google are now either entirely authored by coding agents or almost entirely authored by coding agents, which means humans probably did about 1 to 2% of the work in that change. We see similar trends from our partners in the industry as well. In the recently reported stats from GitHub, about 30% of their merge pull requests, there's been a 30% increase in merge pull requests that they're seeing across their entire corpus. So clearly, agents are here, they're working well, and the volume of stuff they're generating is increasing. But that leads us to a very interesting enterprise paradox. How can we turn this 10x code, 10 times the code being generated, into 10 times the business outcomes that you care about, velocity and productivity, without incurring 10 times the risk? Because as the amount of code is increasing, the risk surface area is also increasing. So today, we are going to spend some time talking through that in terms of various case studies about how we are handling this abundance of code and how it is putting pressure on systems like code review and testing and other places. All of the demos and examples that you are seeing, or all of the stats that we just presented, was all built using Gemini CLI and anti-gravity and other of our agentic offerings that are used broadly inside Google. And so you'll see a few of those things being shown in the demos as well. So with that, I'm going to invite Madhura on stage, and then I'll be back later to close out.
Thank you, Niranjan. Let's get into it. Code review. That was the first areas of investment that we really went after code generation. At Google, about 10% of a developer's time goes into code review and related activities. And if you notice the graph on the right, as code volume started growing at Google, what we noticed is the time developers were spending still hovered around that 10%. That worried us. And we went all in trying to figure out how do we get review to be done by AI, as we don't want to increase risk. And we weren't sure how much of rubber stamping was happening as all these changes went through. The first direction we pursued was we built one central AI review agent that was intended to catch everything for everybody. Guess what? Spectacular failure. It didn't do what we intended it to do. This was about 2+ years ago. There were two major failure modes when we tried this. The models weren't good enough yet for them to be able to catch all of the meaningful, serious things and predictably every single time. So that was one factor. And then the other factor that we observed, this surprised us partially. Developers weren't really ready for AI to mess with their deep flow time during review. Most of them are like, get out of my way. I'm trying to figure out what this is and what do I need to comment in terms of telling this author what needs to be fixed. So both author and reviewer, there was pushback, and they weren't really ready. The users weren't really ready for it. There were a couple more areas where we learned through that initial phase. One of them was there was no way for us to centrally catch all of the variances of different types of code bases, tech stacks, hardware teams, back-end teams, front-end teams, what teams cared about in terms of my best practices. This is what I want my review agent to catch. There was no way for us to centrally kind of figure that out for all of Google businesses. Another thing that we learned was there was no way for us to centrally figure out how much noise tolerance each of these individuals and also teams had. So it was very useful learning. I'll share another story, the second one, which we went in an opposite direction, where the thought was, why don't we just build specialized agents that go after very niche things that are very well defined, and all these things are going to catch all the pieces that we know predictably we can catch, and the rest the developers will catch. One such example was we built a Python readability agent. Google has all the language guidelines very well defined. So Python, we built an agent that kind of caught everything that our guidelines capture. Evals looked great. It was catching everything that we wanted it to. We launched it, and again, it didn't really have the effect we thought it would have. Developers got overwhelmed with everything that was catching. Many of them were nits, according to them. And it actually, for the 1 week that we had this experiment active, developer productivity for the Python cohort plummeted by 9%. And we heard a lot of noise from users. They did not want this thing at all. So we pivoted away from this direction. And these are just a couple of stories to highlight. There was a lot of trial and error in trying things out for us to understand how we could serve all of the different unique Google businesses and the developer needs. And the tiered approach that we landed on eventually was, there are 3 main anchors that I'll describe. There is more to it, but the primary vectors are, we still have a central review agent, but we only cover a small handful of things that we wanted to catch, which is applicable to all of the teams. It doesn't matter which team you are. For example, security issues. So it's a small set that we are hill climbing against and making this better and better for this small set. This central agent is customizable or tunable at an individual level. So people can add additional things that they want to, in a way, add to the pile. And also, it's tunable at team level. So the population can do whatever the specialization, additional specialization they want on top of what we are catching centrally. The second anchor is a shepherding agent. And this agent essentially monitors the in-flight changes and kind of keeps moving it through our CI/CD pipeline, and activates whichever agents are needed to be able to see it all the way through. For example, you might have the review agent do that first review. It goes through build system, build breaks. Shepherding agent goes and tries to fix the issue that caused the build breakage, and then it'll activate the review agent again. So it might do this multiple times to try to see it through till everything in CI/CD clears. So that's another anchor. The third anchor of our strategy is a risk assessor agent. This is scanning all of the in-flight changes for risks, and wherever we find, it's a classifier, whichever in-flight changes have high risk, it adds a tag and says it's a high-risk change. And all of these ones that are tagged with high risk require mandatory review from developers, whichever team owns that particular code base. So trying to catch risk that way. There is another thing that I haven't put on the slide is we're also working through some of the governance and policy aspects so that a lot of the low-risk changes can go through auto approvals without human review. So there is the governance aspect that we're working through. The central review agent that I was talking about, as you can see, it's a small list. We wanted to catch security, reliability, performance issues, the maintainability, whatever we consider important. And the functional and the usability, the two aspects, those are still work in progress. We're trying to find the right balance of what all things should we catch centrally around, is this meeting the functional requirements that a product code base might have. So this one is, we have to figure out whether that remains like a central thing or it goes as a specialization. And the usability also, we're trying to figure out, can we catch centrally if it's a product code base front end, if there is usability, user experience issues, can we catch it actually centrally? So there is some of these are work in progress, but the intention is for this list to remain small. Now I'll show you a quick demo to show some of these things in action. Most of my demos have IDE and the deeper level tools still, but all of these agents are activated or plugged into our anti-gravity agent manager and all of the hubs that are exposing these agents to Googlers.
Let's look at how our agents catch and address a security issue. I've just live coded a server to view file content. The logic is there, but so is the bug, which exposes internal source code. Let's see if our agents can fix this for me. Let me pull up the terminal to see what the review agent is doing at the moment. It is running in the background and it will notify me if any issues are found. As you can see, the review agent found some issues. I can see them directly in the editor, or I can see them in our review tool. Here the agent correctly identified a security issue. In the meantime, our shepherding agent has already started fixing the problem. It will upload the new code when it's done. The shepherding agent finished its iteration. Let's see what fixes it suggested. So you can see here that all the findings were marked as done. This is the fix we're most interested in reviewing, to see if the bug was resolved. Here is the code shepherding agent uploaded to fix the issue.
This was somebody wipe coded a server to read file contents, and it had many issues, including unintentional security issue. And as you could see, the reviewer shepherding agent combination caught all of the issues and ended up fixing and increasing the quality of this change. The next area that started becoming a bottleneck was the AI doom loop. That's what I'm calling it. According to one source, about 12% of a developer's time is going in babysitting these agents. I see a lot of smiles, which means you all are experiencing it too. And natural language, unlike code, is inherently imprecise, and that's just a side effect of that. The big pain points that we started observing was people were ending up with either incomplete or bad design with their code changes. The other thing that we were observing was developers just ended up taking longer time to get this agent to, can you also do this? Can you also do that? And then it just slowed them down instead of getting to that final output that caught all their design intents. So it was slowing them down. And then the last piece we saw was some developers just got frustrated with this babysitting and then will let the agent just do whatever they wanted and then would go back and try to refactor and rework. So that also, in a way, didn't let us get to the velocity that we intended to. One of the things that we ended up introducing to help with this is spec-driven development. And some of the things that this is helping whoever is using this method is they're working with their agents upfront to give them more precise requirements of what all their design intents are, what contracts they want, in a way fulfilled for whatever code is being asked of the agent. And whoever is using, the cohort that's using this ability is ending up with less rework and refactors later down the line. So we're observing that. The other thing that we are observing is the output that is coming out of the cohort that's using this is more exhaustive, thorough. It catches most of the system design goals that we want to see captured. And the readability and explainability of this code is also turning out to be better, so better for maintainability. I'll show you an example of this. In this particular scenario, the developer is done with coding, and then now they're using spec-driven development for finishing up their unit test writing and trying to get to 100% coverage. Let's take a look.
This is a look at spec-driven testing, a new way of understanding, testing, and refining code. The spec-driven testing agent is currently reading my code and existing tests and writing a specification document. The spec will serve as an interactive blueprint for my code, where the agent and I align on exactly how the code should behave and where it proactively services gaps like missing tests and ambiguous contracts. Here's the spec. The green area at the top summarizes the agent suggestions, while the section below details the actual API contracts, including descriptions and pre- and post conditions. I can instantly see which tests are missing, and I'll accept this suggestion and act the agent to act on the new spec. Now the agent is scanning the spec to identify accepted suggestions or any other inputs or modifications I might have made. Then it implements the missing test by editing the test file. Finally, it revises the spec document to reflect the new coverage status. The updated spec now marks the contract as validated by unit tests. And here's the resulting test case added directly to the test suite.
And the last area, this is one of my most favorite one. It's been pretty fun and complex piece of puzzle that we're trying to figure out together, agent observability. So traditional observability, it's more like train tracks. We all know where they are. We all have a good way to observe them, and we know they're not going to move around, so to speak. The other aspect that has happened with the traditional software observability, we all have kind of figured out what all signals are critical to log and what are the standard set of metrics that are worth monitoring for you to figure out what your system health is. And now, arguably, we can, in a binary mode, figure out whether your system is red or green. If you think about agent observability, it feels more like a self-driving car. The intent you give an agent one time, most likely it's going to follow a different path than if you give it another time. And that's going to continue playing out depending on how complex your system is, how large your code base is, how many tools they have available, and what all different paths that these agents can take. The other thing that is still evolving, and we've been having a lot of fun with this, is what all signals to track? What all needs to be logged so that we can make sense of whether the work that is being done by these agents is good, it's efficient, is it high quality, but all of these signals, so it's been fun to and I say, oh, maybe we should take a look at this, or maybe we should start capturing these things. And of course, the scale aspect, it's going to take a lot more. I used to think the traditional logs were getting too big, but with agents, this is going to get out of hand pretty fast. And we had to quickly scale our infrastructure when we started saying, no, we need this, we need that also. And that's another scale problem that's been fun to work through. There are two altitudes that we are thinking of when it comes to tracking agent trajectories. There is, of course, the individual agent trajectory, tracking the signals for user input, everything that the user is doing across all of the turns during a session, and also connecting the different sessions to try to figure out one task versus a new task. We are also capturing what the agent understands. How is it interpreting what the user is saying? The reasoning that is going through the chain of thought, that spitting out the chain of thought of the agent. And also, of course, the steps, for each of the steps that the agent is taking for a task, logging and putting in everything that is happening so we can have access to it at an aggregate. And of course, the agent output. We're also annotating agent output with additional signals so we can try to make sense of, was this output good or not, for however we are trying to match the task and good output. And at an aggregated trajectory level, we're doing path clustering to try to understand multiple things. For example, all of the tools that are being called, is their reliability, and is the set right, the tool set? we ended up seeing with MCPs or not, doesn't matter, a lot of people ended up exposing everything in many different ways, and we kind of went from too much to saying, no, let's think about this differently, and can we actually worry about the things that matter most for the workflows we care about, and then just really hone in on getting those right. We also are able to take a look at token heat maps to find hotspots and figure out if there is inefficiencies in how these agents are operating, and find things like recurring dead ends and whatever systemic issues that we're seeing across these aggregate trajectories. And it was hard to put in all of this investment, but there is a lot of benefits we're seeing through it. Users are finding it easier and are more successful in avoiding the doom loop that I mentioned earlier, because they can quickly redirect the agent, guide it, and move it to the right direction to get to the right output. We're also getting insights into these agents' quality, efficiency, performance, reliability. And it's helping us monitor just the system health of our agent farms or agentic ecosystem, and be able to identify hotspots pretty quickly. And I'll show you a demo. In this example, it's one task that a developer is asking agent to do. To orient you on the product experience, there is a left side tab is showing all of the sub-steps the agent is taking to complete the task. You'll see blue lines, middle tab, that's showing the duration of each of these events, the sub-steps. And then there is another tab on the right that is going to show for each of the steps what all happened. And then
let's look at how Google engineers use this in real life. An engineer has been using an agent to build a new feature. After the last prompt, the agent has been thinking for 20 minutes without making any progress. Using a trajectory, the engineer is able to see what the agent's doing and how it approached the request. Right away, clear the agent has spent all its time calling the wrong tool and doing so over and over again. The agent would have eventually figured that out, but it would have taken valuable time and wasted tokens. The engineer can now prompt the agent to skip that tool and look for alternatives. The agent is now unblocked and making progress. At scale, using agent trajectories boosts efficiency and minimizes wasted tokens, saving time and money.
I've highlighted some of the areas that we have found fun and we've gotten interesting insights from. There's many others that we don't have time to pull out things from. But some of these are definitely helping us capture that 10x velocity and reduce the slowdowns and also help avoid risk by 10x. I'm going to invite Niranjan back. He'll go through some of the scaling and how are we driving adoption so that this all, the goodness goes and is adopted across all of Google. Thank you.
Thank you, Madhura. So everybody here has been following the news, presumably, and the pace of change is just accelerating day by day. Every day, there's a new harness, a new framework, a new tool, a new model, or any combinations of there between. That being said, when you are a large company like Google with 100,000 odd developers, you need to absorb the pace of change in a way that actually makes sense for the organization for the variety of different problem domains that they're going after. We have ML engineers working on machine learning. We have engineers writing front-end code for applications like Gmail and Maps that you use. We have engineers building hardware. We have engineers working on large back-end distributed systems. So we have a wide variety of microcosms across the company. And everything that we do in terms of deploying and scaling AI to these populations requires some thought and planning and be able to carry these populations around. The most important thing when we are talking about the space of change is we need to get our developers to, en masse, change their mental models. Stop thinking less about syntax and think more about systems. There's almost a daily upskilling needed for all of us collectively, and we want to make sure it is as pain-free for the organization as possible. Secondly, the world has changed. Right? We don't just have human employees anymore. We have AI now as a co-pilot or a task delegatee that you can delegate tasks to, and which means that the team workflows and team dynamics are changing. Most people are not, most work, knowledge work is no longer blocked by our 8-hour work limits, right? You could give tasks to your agents, they could run overnight. By the time you come back, they would have done a bunch of these things. And so you have to think about how do you distribute tasks differently. You have to think about how do you plan differently, et cetera. And that requires a broader transformation across the company to be able to really lean into that challenge. Thankfully, we have a lot of really smart people in the company, and many of them are extremely enthusiastic about AI. Some of them are at the bleeding edge, keeping abreast with the latest technology developments, whether it be a new model or a new harness or what have you. And so they tend to develop a good amount of gut feel and gut intuition for what's working and what's not. And they're very effective evangelists. They can go back to their teams and they can share those things. So one of the things that we've done is we've scaled this train-the-trainer approach across the company. We have recruited this network, we call it AI champions inside Google, and we offer them knowledge packs, we offer them hands-on coaching sessions, we offer them an early insight into some of the products that we are building. We solicit quality signals from them so that we know where things aren't working, so that before we roll them out to a broader population at Google, we can quickly correct and fine-tune them. And then those AI champions can then really go and scale this across a variety of their organizations as well. There's two really important advantages of that. First and foremost, there's a very rapid feedback flywheel for our products. The more people use anti-gravity, the more people use Gemini and all the other underlying things, the better they're going to get. And especially when things are going wrong inside Google, we can actually channel that feedback to our friends in Google DeepMind and work with them to build fixes and better solutions there. But there's also another interesting learning flywheel that happens where there are teams in YouTube who discover a new way of working, and they share it with people working on Google Maps. And so there's an infectious knowledge spreading that happens through it. So the community building is super important. As a part of that, we build and share a lot of dashboards across the company. At this point, most major companies have some sort of an internal token use dashboard. We have similar ones, but our goal is to really help engineers understand where their tokens are being spent and use them effectively for the right kind of meaningful tasks, et cetera. But we also track a whole bunch of other metrics, like what is the adoption rate of AI, how much velocity gain are you seeing in your product because of AI, et cetera. And as a result of that, we're able to really kind of bring this community along and keep staying at the frontier of what's possible with AI. The next thing is about scaling responsibly through agents, right? Our current thesis of what we're seeing emerging is there are two broad classes of agents emerging. The first one is something that we call as personal agents. Like, so if you use anti-gravity or Gemini CLI or Claude Code, that's kind of your personal agent, runs either with your permissions or runs on your computer, et cetera. One of the things that we are trying to do at Google is we want to make sure we are tracking everything that agents are doing uniquely so that we can attribute it to agents, and that way we can distinguish between human responsibility and agent responsibility. And so with the personal agents, we are trying to really create those capabilities where giving every engineer a sandbox that they can run their agents effectively in without worrying about any sort of unintended side effects that might happen. These agents can do a lot of things on behalf of you, and they can inherit your permissions, so they are pretty powerful. And so we try to add interesting checks and balances along the way to make sure that they don't go off track. And we also, these agents learn from you and your behavior and what you do. And so you can do some kind of hill climbing on your own tasks as a result. We also have this category that we are calling team agents, and Madhura showed you a couple of examples of the code review one. And there's a lot of tribal knowledge that resides within a team. Best practices, coding standards, certain ways of deploying, certain ways of managing your sprints, whatever it might be. Those are pretty important for those agents to know if you're going to invite them as virtual team members of your team. And we want to make sure we are really capturing those team-level practices, allowing agents to infer them dynamically if possible, and then let the teams collaborate with those agents at scale. We just talked through a few examples, so I won't cover there, but we're seeing increasing adoption of these over time. Finally, we want to get to 10x velocity without 10x risk. In the last 6 to 9 months, there have been incredible advances in agentic coding across the industry, right? And as a result, what we have effectively built is a Formula One car, but we haven't built a racetrack. That Formula One car is still driving through the gridlock streets of whatever major city you want to pick here. And so you could go from one stoplight to the other very fast, but you're still going to stop at the next stoplight about 30 seconds later. And if you want to really get the 10x acceleration, you have to rethink software engineering fundamentally. Right? Coding agents are contributing significant volume of code, but it means there's a review burden. It means there's other bottlenecks, and your risk is also compounding, and you have to think very carefully about those. There are specialized agents that are coming up, agents that are highly capable, but you have somehow constrained them because you've only given them limited permission, so you've sort of fine-tuned their sandbox. They can be pretty powerful, and in fact, they can actually help you reduce your risk and technical debt. Right? Code is not just an asset, it can be a liability. The more code you have, you're likely carrying more risk. And if you actually use agents correctly, if you use agents in a way that are trying to solve your technical debt challenges, you might actually improve your risk posture as a company. And finally, activation is an incredible challenge. In most organizations, we see a wide distribution of AI fluency, even if people are using AI. And I think it's a constant battle and challenge for us to make sure everybody is at or as close to the frontier as possible. Because this technology is evolving so rapidly, you don't want to be left behind. But you also want your teams to be doing it in a safe and predictable way. So education, community building, best practices play a big part here. That's it. That's all we have here for today.